So here's our third bonus lesson, integration by partial fraction decomposition. So let me go over a little review here. Let's say we were given this integral. So 2x minus 1 all over x squared minus x minus 6 dx. If you were to see something like this, you could use substitution. That's one of the first things we learned. Right? Because you can look at the denominator and say the derivative of the denominator is the numerator. Right? You get 2x minus 1. So you could say u equals x squared minus x minus 6, and du would therefore be 2x minus 1 dx. And if you did that, you can make the substitution where you'll get 1 over u du. Now, the integral of 1 over u is the ln of u. We've sort of gone over that before when we did derivatives, right? The derivative of the ln of u is 1 over u. The integral is the opposite, except we need to add that constant for indefinite integrals. And then we can just replace u back with x squared minus x minus 6 plus c. All right, but what if I were to give you an example that looks like this? We'll have the integral of 3x plus 11 all over x squared minus x minus 6 dx. So in this case, the derivative of the denominator does not equal the numerator. Substitution is not going to work for us in this case. So what we're going to do is something called partial fraction decomposition. So let's take a look at this fraction in here. So let's just ignore the integral for now. And what I want to do is take this fraction, 3x plus 11, and we'll notice that we can factor the denominator. It can be factored into x minus 3 and x plus 2. And what I want to do is I want to write that as two separate fractions. One with some numerator a divided by x minus 3, and one with some numerator b divided by x plus 2. So I want to split it. Now to do that, I need to figure out what a and b are. Alright, so what I'm going to do is, even though my goal is to split it, I'm going to combine them first. So combining fractions, what we will do is multiply both fractions by a common denominator, which would be the multiple of both those denominators. And when we do that, we get this. So we get a times x plus 2 plus b times x minus 3 all over that common denominator, x minus 3 times x plus 2. So here we have an equation where the denominator is the same on both sides. So what we want to do is therefore just equate the numerator. So let's just look at the numerator here. 3x plus 11 equals a times x plus 2 plus b times x minus 3. My goal is to solve for a and b. Now I can do that using a couple values for x. So I know, for example, if x is negative 2, a is going to disappear because this bracket's going to be 0, and 0 times a is just going to be 0. So let's look at that. If x is negative 2, what do we have? So we have 3 times negative 2 plus 11 equals, that whole term is going to be 0. So I am left with b times negative 2 minus 3. And now I can solve for b. Right, over here I'll get 5 equals negative 5b. So b equals negative 1. Okay, now I can do the same thing to find a, because you'll notice if I make x 3, this term here is going to be 0, so b is gone. So if x equals 3, we end up with 3 times 3 plus 11 must equal a times 3 plus 2. And now I can solve for a. So here I'm going to get 20 equals 5a. So a equals 4. All right, now I can go back and split up this integral into two separate integrals. I can say this equals the integral of a, which we know is 4, over x minus 3 dx. I'm using the property of integrals here, so I can then subtract 1, right, because I have minus 1, so I'm adding negative 1. So 1 over x plus 2 dx. And these are integrals that I can do. The 4 I can bring outside the integral. It's just a constant, so we'll get 4 times the ln of x minus 3. Same with the 1. I'll bring the 1 out, so minus 1 times the ln of x plus 2. And then we simply add that constant c. So that is how you can find the integral of a fraction like this, where substitution won't work, using partial fraction decomposition. So I want you to try one for yourself. So try, just to make sure you understand it, the integral of x squared plus 4 all over 3x cubed plus 4x squared minus 4x dx. And what you should get is minus the ln of x plus a half times the ln of x plus 2 plus 5 over 6 times the ln of 3x minus 2. Notice in this case you're going to have to split it into 3 fractions, a, b, and c. Plus c.